Algebraic proofs. Well, a proof is simply, like it says, an argument that uses logic to show that a conclusion is true. I mean, you sit there and you think, well, you want to prove something, you have to have proof. Logic and arguments and statements that say, hey, this is true because of this, and this. Now, you've seen these properties before. What I want you to do is make sure that you have these into your little books because we are going to be needing them. So give you some time to get that in there. Okay, so what we're going to be doing is using these properties to help us prove that the answers that we get are correct. So, we're going to write an algebraic proof. Now, you guys know exactly how to do this. If I give you x plus 1 is equal to x plus 9, what's the first thing you do? Distributive property. So you'd rewrite this as 2x plus 2 is equal to x plus 9. Is that correct? So I've done the distributive property. Next thing we would do is we could subtract 2, subtract x, subtract x. And we would end up with x is equal to 7. Is this correct? Yes or no? Now, how do I turn this into an algebraic proof? This. We are always given the information to start with. We can't go from someplace we don't have anything to begin. So the first thing that always gets put down for a proof is given. Now, what did I do here? How did I get to this next line? What did I do? Well, let's see, that was, let's see, do we have distributive property? Do I? So, what do I call that? I mean, we got these are properties of equality. What do I put down? Because it's not here, is it? What do we put down? Well, what did you use? We said we used the distributive property, so is that legal to put down here? Is that legal? Is that the rule that I used? I mean, that's how I got from here to here. I used the distributive property. So now, how do I get to the next part? What did I do here? Well, this was done to one side, distributive property. This is done to both sides, so it must be something to do with the equality. So, which one of these did I use? Did I add something to both sides? Did I subtract to both sides? Did I multiply? Did I divide? Did I use the symmetric? Did I use reflexive? Did I use transitive? Did I substitute? What did I do? Well, when I look at this, it looks like I subtracted 2 to both sides, subtracted x to both sides, right? So, would that be the subtraction property? And we're going to put an equal sign back there of equality. Is that what I used? And that's it. So how did I get to x equals 7? Simplify. I just did the math. This is an algebraic proof. That is a justification for each step. Now, if I can't justify the step that I'm doing, then I can't go and do that. That's just what it is. So it's kind of like understanding and knowing the procedure for doing a problem. Let's try this. If I got this, I got 3x minus 1 over 5 is equal to 2x plus 3 over 3. So, for those of you not paying attention, what do I got to do? I suppose what I could do is multiply everything through by 15, right? If I were to go and take 3x minus 1 over 5 is equal to 2x plus 3 over 3, multiply this side by 15, multiply this side by 15, with that get rid of my fractions. Because that would cancel with that, I'd end up with 3. So I would have 3 parentheses 3x minus 1 is equal to, this cancels with this. And I end up with 2x plus 3 multiplied by 5. What would I have to do next? Distributive property. So that would give me 9x minus 3 is equal to 10x plus 15. Be my next step. Wouldn't I want to go through and subtract 10x to both sides? Add 3 to both sides? Then I end up with negative x is equal to 18. Well, that's great. That's negative x, but I want to know what is x. So I can multiply both sides by negative 1. And then what do I got? X is equal to negative 18. So, how did I get here? What were the rules? Well, this is what I started with, right? So what's the reason that is there? Given. Okay. What did I do here? Well, did it happen on both sides of the equal sign? Yep. So, if I go back here, what did I do? Oh, I multiplied both sides. Okay? So, this was multiplication property of equality. That was the reason for that. So, how did I get here? What did I do? Well, wasn't that the simplify? Didn't I simplify things? That's all it is that I have to say. I mean, that kind of takes us through the algebra. What did I do here? How did I get from here to here? For those of you not paying attention again, what is it? Well, would it not be distributive property? So I simplified. I did the distributive property, got me to here. Now what did I do here? Well, I added it and subtracted, right? So could I write it as add slash subtract? Because it's basically the same thing, isn't it? Add, subtract, property of what? Equality. How did I get down here? I simplified again, didn't I? Then what did I do? Well, didn't I have to use the multiplication property of equality? There. This is a proof. In geometry, when we're working on things, we always want things to come out in the form of a proof. Why did I do it? What justification? We start off with algebraic proofs because you guys have a fairly good idea of the algebra. So, let's take a look at this. Is this correct? No. Is it? Question starts off, what is always the first thing going to be? Given. You gotta, if I want you to do something, you have to be given the assignment, correct? You have to be given the information. If I just tell you to go do, you don't know what to do because you haven't been given any instructions. So, that's not simplify, that has to be given. Okay? So is the next rule appropriate? Okay? Is the next rule appropriate? What should it be? Subtraction. So division shouldn't be there. This should be subtraction right there. Okay? Is the next rule correct? No, that should be what? That should be the simplifier. After all, how do I get from -6 minus 2 to -8? Simplify. So, what should be down here? Okay, that is where the division should be. Is simplify correct then? I mean, it's pretty obvious when you actually take a look at it and see what was done. Does this rule match? What was done? Does the rule match? Fairly simple and easy to do. And you should always do that when you're writing out your proof, just to make sure that you've got the right things there. Now you'll notice that there's an awful lot of writing for this. This is the answer. This is not the answer. The whole thing is the answer. You have to have it all. Now, will it always be in the same order? Sometimes not. It all depends. I mean, if you were working on this problem that I had done over here, and you said you wanted to add 3 to both sides and then do the subtraction, you could do that in 2 different steps. So there is going to be a little bit of variation that goes on here. Okay. Say this. The area of a rectangular patio is 28 feet square. The patio's length is 3x plus 1 feet. The patio's width is 2x. Find the dimensions of the patio. Provide a justification for each step. Let's see. When in doubt, draw it out. Always works. So, let's see. Patio's length, 3x plus 1, width, 2x. So now, my starting point is going to be here. 3x plus 1 gets multiplied by 2x, and that's equal to 28 feet square. How do I know this? Okay, it tells you. It tells you. What word do we use to identify that? Thank you. Okay, what should be the next step? If I multiply this out, that gives me 6x squared plus 2x is equal to 28. Right? Is that a good way to do this? So we're there. What did I do there? What's the rule that allows me to do that? Distributed property. Now, if I am going to go and work through this, I need to go and get this thing set up as a quadratic. So that's going to be 6x squared plus 2x minus 28 is equal to 0. So I want to make sure that I'm showing all my work with this, so what do I have to do to get to that point? Subtract 28, subtract 28. Okay, what did I do? Well, this would have been subtraction property of equality. What's over here? Well, that's just a simple one. Now, what do I got to do next? If you guys remember playing with these things last year, okay, well, I'll go through it with you. There's a 2 that's in common, so I can factor out a 2. So if I factor out a 2, divide this side by 2, divide that side by 2, I end up with 3x squared plus x minus 14 is equal to 0. What did I do to both sides? I do the divide, oops, sorry. Actually, I shouldn't say I can just do this. Division, property, equality. How did I get to here? Simplify. Now, rest of the way. Well, this factors. Okay. So, I need to factor this. I need to get to a 3 and I need to get to a 14. Let's see, one of these is positive, one of these is negative. So, what I end up doing, get 3x here and x would go over here. I need that x to be positive, so that turns out to be 7 here and 2 there, if I'm not mistaken. Okay. So, how did I do that? Well, that was just simply a factor. There's a whole process with that. So, now, 2 possibilities. 3x plus 7 is equal to 0, or x minus 2 is equal to 0. Okay, simplify. Let's see, subtract 7, 3x is going to be equal to negative 7. Add 2, x is equal to 2. But I have a question for you. Is it possible for something to be negative in distance? Can distance be negative? No. So this one here doesn't work. This one here does. 2. So x is equal to 2. Now again, here was the addition property of equality, and then a simplifier. Okay? And that's it. All we need to be able to do is justify each one of the steps that we have. So, I'm going to give this one to you, and I'm going to give you a minute or so here to go and take care of this. So after you get down to given information, then what is the next line that you did? What do you mean you don't know? What is it that we're trying to do here? Oh, no, the first command here is to solve the equation. So what would you do next to solve this equation? Okay, so we'll go there. So you subtracted 5 and subtracted 5, correct? Did you do anything else with that step? Okay, you did minus x. You subtracted x here and subtracted x like that. Nope, that's not supposed to happen. Well, it should be this way, minus 4x, minus 4x. So, now, you subtracted, okay, so what was the justification for this? Well, yeah. What operation did you do? It isn't that difficult. What operation did you do to both sides? What operation is that? Addition, subtraction, multiplication, or division? Okay, good. So we did the subtraction property of equality. So, now I realize that we're slowly going off. Some of you might have done something a little bit different, but okay, yeah. What should be the next line underneath it? Okay. Okay, so what would be here if I subtracted? If we have an x here, what number is in front of it? 1. So if that's 1x and that's negative 4x, what would I have left? 3x. Would I have anything left here? Would I have anything left here? What do I have here now? Well, actually, it's 2 minus 5. Okay. So, we did the math. We worked it out. So that means that we had to have a what here? What do we call that when we work it out? Absolutely correct. Simplify. So, if we take a look at the next step, what do I got to do to both sides? I wouldn't multiply. How would I get rid of that negative 3 that's in front of the x? Ah, there we go. So I divide by a negative 3. So what do I got to do to this side? Divide by negative 3. So what would be the rule then that we used? Division. Property of what? Equality. So the final line in this whole thing should look like this. X is equal to negative 1. So what is it that I've done? Simplify. Oh, you're right. Yep. Should be positive. So that's that. Now, I want you to go through, and I'll give you a couple of minutes to work on this. Okay, let's get this one. So, Leah, what would be the first thing that you would write down here for line number one? Okay, so you want 4x plus 5 over 3 equal 5x plus 7 over 4. And what's the reason given? So, hey, Gavin, what do you believe should be the next step? Cool. So that means that we end up with 12, 4x plus 5 over 3 is equal to 5x plus 7 over 4 multiplied by 12. And what would be the reason that we would do that? Well, yeah, I know that's because that's the reason why, but what's the rule that allows me to multiply both sides by? That's where you look in your little book and you look at that. Add, subtract, multiply, or divide. Okay? So, multiplication, property of equality. Now, as you go through and do this, you will realize that there are really only four things that we use: add, subtract, multiply, and divide. Well, that's off that table. Simplify is what we use to signal that we did some simplification, we did some math, we did the algebra. So, when I get down to this next line, what should I write down as my reason, Caleb? This is simply going to be a simplify. Why? Because that cancels with that, and I have 4, so I end up with 4 parentheses, 4x plus 5. Cancels with this, and I get a 3, so that means that I have parentheses 5x plus 7, the 3 out there. So, now I need to do the next step. So Hope, what would be the next step? Okay, well, the whole word for that when we're taking a number out in front of a parenthesis is what? Distributive property. So we got the distributive property now that I used. So that gives me this here, so I end up with 16x. This over here, so that gives me plus 20. And here, that gives me this, and I get 15x. And here I end up with plus 21. Okay, so up there, distributive property. So, Hannah, what do I do next? Subtract what? Like that. Anything else you want me to do? Okay. So, what's the rule that allows me to do that? Okay. So that's the subtraction property of equality. So, I get down to, well, what should be the next line then? Okay, so that's going to be a simplify. And that leaves you with x is equal to 1. Am I done? Yeah. All this is just an algebraic process. Now, I realize that by going through and writing out the reasoning, it's rather bothersome and it's a lengthy process. But when you are going through and doing this, these are the steps that you use. Okay. So, that's that. The assignment is going to be due at the end of class